Hello everyone, welcome to the channel and I hope everyone is doing good. So this is the data migration series and today's video is the first episode. I will be coming up with around 2 to 3 episodes which in the final episode I will be demonstrating in the practical data migration project. So this is the basics of data migration, but this is one of the most fundamental and very important videos on the data migration. This will set a good platform if you have not undergone any data migration actual project. Okay, so let's start the video now. So in this particular video, we are going to focus on what is data migration. Why do organizations need or migrate data? What are different types of data migration? What is the common source and the target system? What is a typical migration architecture looks like for a data engineering perspective? What is batch versus real-time migration? And what are the common challenges and risks? So data migration, don't think a data migration just copying the tables data, copying the database data and moving into different data. That is not going to work. For a data migration is a process of moving data from one system to another system while ensuring that the data remains accurate, complete, consistent, secure, and usable in the target environment. You can have database to database migration, you can have an application migration. So data migration involves multiple things. It's not a straightforward just copying the data. Your data should be meaningful when it is getting migrated to another system or another database, and it should be usable from the business point of view. Fine. So we'll look into everything in detail. Now, why do organizations perform data migration? Now, before that, you see here, there's a simple migration flow I have created. So you have a SQL server and you want to migrate your data from SQL server to Snowflake. So there is a data migration through S3 bucket. I'm using S3 AWS in the middle architecture. So we have S3 bucket where you can put the raw data. Then you can transform with the help of Spark, Glue, or any other. You can use a normal SQL also, and with the help of that you will put in the Snowflake. So we are moving the data from SQL server to Snowflake. These arrows may look very simple, just moving the data, but there are multiple things going behind this arrow. Okay, we'll see it as we proceed in this series. We'll see what is the inner meaning of these arrows, what all the transformation we do, how we do the reconciliation, how we do the testing, validation. So why do organizations need data migration? So there are multiple reasons for it. The first is the legacy modernization. Like if an organization is working, having a data for around 10, 20 years in Teradata system or in an IBM system, and now they want to modernize their system so that they can use multiple feature in the modern technologies. So that is legacy modernization. There's a cost optimization. People want to move from the on-prem database to the cloud database, and that will help them to scale their system, reduce the cost, and the same thing they are doing. People are doing with the cloud migration. In fact, organizations are doing for the cloud migration. When there is a merger and when company, like for example, company A buys company 2, and company A is using, for example, AWS data or Databricks data lake, and company B was using some Oracle legacy system. So in that case, also data modernization happens. Data platform modernization, multiple times the full platform gets modernization where the observability, monitoring, full data compute, like for example, people are moving towards the database or organization is moving towards the Snowflake. The full platform modernization is also taking place. Data modernization is very important topic for all the data engineers of any years of experience. If your year of experience is more, you will see more of these scenarios. You will have multiple responsibilities in the data migration project. But this is very important topic. Now, data migration is not just copying the data. So this is a simple diagram I have created with help of one chat GPT. So there is a source system. We assess the source system first, means we look into what are the tables, what is the amount of data, and what we are going to migrate. Then we do the data profiling, means we are looking into schemas, we are looking into data types, we are looking into multiple other things. Then there is a schema mapping, source to target. For example, I'm moving from one database to another database. In one database, I have customer underscore ID. In the another database, I may have customer customer underscore ID or identification number. So column has to match. And am I going to create any transformation in the source to target mapping? So that is schema mapping. Then data extraction. How we will extract the data from the source system? For example, my source system is Oracle, and I'm moving towards Snowflake. So how I will extract data from Oracle? How I will do the transformation? What technology and what compute I will use to transform the data? What is the data loading? Where I'm going to store the data? Am I going to directly store into Snowflake? Am I going to store into S3, then into Snowflake? If I'm going to store into Snowflake, then what will be my raw layer, landing layer? What will be my silver layer? So this has to be decided before doing any kind of migration. Then there is a data validation, data reconciliation, and there is a cutover time. Like for example, now earlier your reporting system was directed towards your source database, like Oracle, but now you have moved the data from Oracle to Snowflake. That means your reporting reports which were pointing to the Oracle need to repoint to the Snowflake. So that duration, like that you have to move the connection, then there will be a cutover period in the production. So how you will manage, how you will reduce the cutover time, and what will be your target system? These are the questions which should come in your mind before starting any data migration project. So this is generally for a people who are having 7 to 8 years of experience. So they will get a full project of data migration to lead it. So in that case, you have to come up with set of questions for each of the section to the client, and then you can start your data migration by phase. Okay. Now there are different types of data migration, like a database data migration. You are moving from Oracle to Snowflake, you are moving from SQL Server to Postgres, or you're moving from Teradata to Snowflake. So the other one is storage migration, like on-prem file system to AWS S3. If you want to move from the, like you have an on-prem, your own server, you want to move to the cloud S3 bucket, S3. So that is a storage migration. There is an application migration. For example, you have a legacy application where Oracle database, files, or SQL database, or some interfaces there, and you want to modernize everything and want to move into the cloud, like cloud application, cloud database, APIs, cloud storage. So that is called full application migration. In storage migration, your application may have moved to the cloud layer, or it have not moved to the cloud layer. It doesn't matter. Only your storage moves. So when your storage moves, your application repoint to the new storage. But in application migration, your full application, including the storage, moves to a new system. There's a data warehouse migration. This is very popular. I think since last 10 years, people are doing multiple data warehouse migration. Now people are moving towards Snowflake. They are moving towards Delta Lake of Lake House of Databricks. So data migration is very important. Any level of experience of data engineers should understand what is data warehouse migration. And before that, you should understand what is data warehouse, what is the advantage, disadvantage, and what are the new ways of managing the data warehouse, like in Databricks and in Snowflake. That also need to be understood. If you want more detailed videos on how data warehouse has evolved from a traditional data warehousing to a modernized data warehousing like Snowflake or in a Databricks, do comment it in the videos. I'll come up with a separate videos. Now there is another thing, understanding the source and target. Like whenever you get a migration project, there are few set of questions which should come in your mind regarding the storage migration, regarding the storage part. Like how many database you want to migrate, how many schemas are there, how many tables are there, what is the data volume. Data volume plays a big role because that will impact your data extraction, data transformation, and almost all the layers. What is the daily data growth? Like for example, your Oracle system is getting the data from a retail. So when we migrate the data from Oracle to Snowflake, but in that case, Oracle data will be continuing to receive the data from the retail system. So what is the growth of the data? What tables are very critical, so that you have to take a special, you have to consider a special validation on top of the tables. What are the historical tables, just in which you need to do just lift and shift? You have to just copy the data and bring it into the new system. That's a historical node. Which tables are no longer used? So while modernizing this storage or modernizing the platform, you have to also understand that which all tables were not being used in your source system. So you can either archive it or you can delete it as per the application manager or application owner suggest you. So what are the upstream and downstream dependencies? Like for example, your database, who is generating your database and who is using your database, means who is using your data. So you have to understand all these things before going into any kind of activity of data migration. The important thing is data profiling, which I have mentioned here. In this diagram, you will see there is something called data profiling. So what is data profiling? So data profiling is checking how many are null values in your table. Like for example, I have an employee dimension table. So how many null values are there? How many duplicate records are there? How many invalid values are there? What is unexpected data format? So for rules for getting the invalid values should be should get from the business analyst. You have to be in touch with the business owner or the application owner, and from there we'll get about the invalid values, which value need to be taken into account as valid and which has to be considered as invalid. What is referential integrity? What is data distribution? Everything about the data inside the table is called data profiling. You can create your own framework which will do the data profiling for all the system. There are multiple frameworks in the market. In fact, there are many systems in between Databricks also. You can do the little bit of data migration, data profiling in IDMC. You can do the data profiling. So data profiling is very important. Get into detail of this. I have just given the overview of it, but there are multiple other things also in the data profiling. Then there is source to target mapping, which we call it STTM, source to target mapping. For example, when you are moving from Oracle server to Snowflake, so which column will be renamed into Snowflake? For example, the other thing is if I have a something called multiple cost, multiple record of a cost in a SQL server, and in Snowflake, I want to create an aggregation of that. So which combination of many to single, many to one source to target mapping, or one to one source to target mapping we have to consider. So before doing any migration, there is always a source to target mapping is being done. And the source side, you can understand it from the source profile data profiling, that what are important columns are there, and accordingly you can match it to the Snowflake. See, your migration, in when your migration will complete, then actual data will land in the Snowflake. But before that, you should have a plan that what all columns has to be present in the Snowflake so that you can create a source to target mapping. Understand data type mapping. For example, you're moving from SQL Server to Snowflake. So integer will be called integer here like this. Date time will be considered the timestamp. So whenever there is a data type mismatch or data type change, you have to you have to take that care in the logic itself. You have to write a script on top of it. You can write some inbuilt function, and you can call that function in your script so that this data type conversion takes place smoothly. Otherwise, what I have seen in most of the migration, people or the team spend a lot of time in doing the working on the mismatch of the data type. So if you take this into account before doing the data migration, then your migration will be smooth. Data migration will be smooth. Now, this is a common data migration architecture in which I have a source system. For example, this is a common migration system which a data engineer follows. There will be a little bit changes on this, but the whole theme remains same. Like in the source system, I have Oracle, SQL Server, Teradata, maybe any one of the source database system, or there can be multiple data system as a source. You have to first create an extraction layer. You can use either JDBC connection, you can use any API to extract the data from this source and put it into landing zone. Your landing zone can be AWS S3 bucket. Your landing zone can be any other things like Snowflake. Then there is a transformation layer. By using the input as the raw data, you can transform the data if it is required in your migration system. But in the modernization system, almost all the system will require the transformation unit. So you can use a Spark, Glue, you can use a normal Python framework, and then there will be a platform, target platform, where you are going to store, or you are going to create a data warehouse. So that will happen in the Snowflake, that will happen in the Databricks, or any of the system. You can have the full target data warehouse in the S3 bucket itself. So this is the how it goes: source system, extraction layer, transformation layer, and there is a target platform. Now, what's the difference between full load and incremental load? Full load means you want to move a full historical data. Means that data is not growing. That data is already in the source system. You want to just copy the data and move into the target system. That is a full historical data. And like for example, in the source system, I have 500 millions of record, and in the target, I'll just bring this 500 millions of record. That kind of data is not growing. But incremental load, you have to check. Like for example, today I have run a job which has extracted around 1,000 records. So tomorrow when I will run the job, the extraction will happen after 1,000 records, because in the source system, your data is also growing. That is called incremental load. The other thing is, other one more thing can be here. Like for example, you have a data in the source system which is having a huge number, a huge amount of data that is not growing. But in a one chunk, you don't want to migrate. You want to migrate by running multiple batch job. So in that case, also you can implement the incremental load. So we check this. If you're using Glue, there's a bookmark, watermark. With the help of that, you can do the incremental load. You can do CDC, you can do SCD type 1, SCD type 2. These are the concept of data warehouse. If you want to know more about it, you can put it in the comment. Like typically incremental load, how it happens. So initially, there will be a full load. That is step 1. Step 2, the source and the target are being synchronized. Synchronized means you are getting the data from the source, doing the CDC and putting into the target. And there is a cutover time and the new system is not ready. Batch migration and real-time migration. Batch migration, like you want to move a full historical job. Your batch migration, like incremental job, historical job can also happen in a batch migration. A large batch processing. Now, in real time, I'm just going a little bit fast so that I will cover up it in I think less than 30 minutes. If you want to know more about any particular portion, you can post in the comment. I'll just come up with a separate video. In real time, like your data is getting generated. For example, the sensor. For example, there are multiple sensors in your in your system for the car sensor, and that car sensor is collecting data continuously and putting into some database, and from there we have to get the data into our analytical data warehouse system. So in that case, we need a real-time system or we need a near to real-time system. Either you can use Kafka. Near to real-time is there is a small gap in generation of the data and acquisition of the data. So you can use Kafka is very popular in that, and I have done multiple use case in Kafka. You can use AWS data migration services. You can use Debezium. Debezium takes care of CDC. It will do the incremental load also in Debezium. Kinesis is there, the AWS service of Kinesis that is very similar to Kafka. So, what is the biggest challenge in the data migration? The biggest challenge is the data validation. So, data validation means the kind of data what you are getting, like or when you are doing the migration, is the data having the correct information. So there is a schema validation. You have to take care of the schema validation, the record count validation. These are self-explanatory. You can understand this. Aggregation, like some count. So whenever there is an aggregation happening in the source system and you have to migrate that into target, then you have to take care of it. Because in the target, you have to again calculate the sum and aggregated values. In one-to-one column, you don't have to create any logic, but here you have to create the logic. So aggregated columns need to be taken special care. Row level validation, like there are multiple frameworks which will do each row validation. If you are having a transactional system, if you are working on a insurance or banking project and that data is very critical, so in that case, row level validation is very, very important. And there are multiple frameworks. You can also create a frameworks, but that computation is a bit expensive in this. Data reconciliation, counting the records. Now, data reconciliation is a business reconciliation also. Like in validation, you only check that data is technically matching, like record count, number of number of columns, schema match. But in reconciliation, we take from the perspective of the business side, like does the migrated data make sense? Like total premium, total claims, like what I have mentioned about the aggregated columns. These comes under the business perspective, and that has to be taken different in a different way. And like in the initial, I think a few years, 10 years back, I think I have created, yes, for one of the project, I have created a very good reconciliation framework for one of the leading banks, investment bank, and there was some threshold limit also. Like if the reconciliation values crosses 10%, means 10% of reconciliation is not matching, then your job should fail, and you have to look into the logic again. So that kind of reconciliation framework can be created. If you want to know more about creating how to develop a reconciliation framework, put it in the comment and just create a different video. Common data migration challenge. Like before doing the migration, multiple challenges are there. As I have mentioned, there are multiple questions you have to ask, or you have to ask the business side before doing the migration. Poor data quality. The source system already have a poor data quality. In that case, the migration becomes difficult because you cannot uh, just copy a poor data into a new system. You have to first clean it. So like duplicate data, missing data, invalid values, inconsistent data. So that need to be taken care of. Schema differences. If you have a large data volume, then you have to think on like how you can extract. You can have to use a distributed processing like Spark. You have to think of a cluster cost. So how do we partition if you have a data a very large volume? Obviously you have to partition it so that later a period of time the reading of data can be done or the scanning of data can be done in a small chunks, not as a full chunks. How do we transfer the data? Either we have to use any DMS service. I have seen multiple data as a video data which are of very huge number. In that case, AWS people just go there and do the in the Glacier storage, they just copy the full storage. So multiple times there are different approach you have to take it. And how do we restart the failed job? For example, you're pulling the data from S3 to Snowflake, and that your job gets failed. So if your job gets failed, that means some of the record would have been copied to Snowflake, and some of the records would have not been copied to Snowflake. In that case, how you will implement the restartability of job, and also to take care that your record doesn't get duplicated in your target system. It's a very important question. There can be a very different separate videos and detailed videos on the restart failed jobs. You need more details, put it in the comment. I'll come up with the new videos. Downtime, like cutover, you have to reduce the cutover time, so that comes under downtime. There are data dependencies if you're working on insurance project, banking project. So in this kind of project, there are dependencies on multiple tables. So you cannot directly just copy one table and put it into target system. You have to look into dependencies. You have to first copy the data which is very low in the hierarchy, and then you have to go one by one up into hierarchy and the copy the data. So that plan has to be created before doing the migration. Performance also need to be taken care, like how many parallel extraction of the job has to be taken place, what should be the file size, what should be the chunk size, which kind of format you want to put, CSV or Parquet, how many target loading threads are there. If you're not using data distributed data processing, then loading threads has to be created, and how it impact the production system. Now think of a migration framework thinking. Now see, you have multiple tables in a source system. You have a customer data, you have the transaction data, you have department data. So we'll not create each pipeline one by one. Then there, it will be a multiple pipelines and it will be very difficult to maintain it. So in that case, you build a single or a couple of pipelines which is built on a metadata driven framework. That means there will be a config file, a metadata, where you will tell what is your source system, what is your target system, what is your load type, full load, incremental load, what is the primary system, partition. And according to this, you will write a logic in your pipeline, and you will just change the parameter, and the same pipeline will run for a different parameter. So for each table, for each source, in fact, each source system, you are not going to write a totally different pipeline. But if a pipeline needs a totally very different logic from the other pipeline, then you have to write a very separate pipeline. A framework will extract the data, transform, load, validate. It's a general, and then it will report. So this was all about data migration episode 1. So I have planned for at least 2 more episodes, in which the last one I'll come up with a practical implementation of data migration. Very important. I think I have covered all the fundamentals which is required to start with the data migration topics. Go through it. Any doubt, put it in the comment. Connect me through LinkedIn or through my email address. I'll surely help you whenever I get time. We'll meet in the next video. Till then, happy learning and goodbye.